All right, hi geometry students. Let's take a look at 6.7 arc length notes. So arc length is going to be talking about how long is an arc. So we're talking about right there, for instance. So how long is this arc? You can't measure it with a ruler because it has a curve to it. So how are we going to do that? Well, it's going to have a lot to do with central angles and some fractions. So first, let's talk about the definition of an arc measure, the measure of an arc. And you're going to measure the arc in degrees. So we already know all the way around is 360. If we're going to say arc length, that's going to be the actual length of the arc. And again, you can't measure that with a ruler. And that could be in feet, inches, yards, etc. It'd be like as if you straightened it out, the curve, and then could measure it. But obviously it's on a piece of paper, so you can't just straighten it out. So let's take a look at what we have right now. We have a central angle located at 30 degrees. So that's important. So here we have 30 degrees. That is what we call a central angle. Again, that's going to be a key thing we're going to be using. So the central angle. We have three different things we're going to be measuring. We're going to measure arc AB, arc CD, and arc ED. Well, it's very easy to find the arc measure because we have a rule for this. We know that if the central angle is 30 degrees, then the arc measure is also 30 degrees. So even CD has the same central angle, so that is 30 degrees. And arc EF has the same central angle, so that is also 30 degrees. So notice that it's always 30 degrees, but if we were going to actually measure it, straighten it out and measure it, you could tell that it is getting bigger. So that would be arc length, not arc measure. So we know that the smallest one, just by looking, is arc AB. And then we've got arc CD in the middle. And then lastly, arc EF is the biggest arc on there. Okay, so let's go ahead and take an investigation. We're going to find out some information given R is 6. So they're going to tell us that the radius is 6 here. So let's see. Very important that we read that. All right, so it says the measure of circle Z. So all the way around, we know that it is 360 degrees. Again, measure is going to be talking about degrees. So that's a full circle. So first, let's find the circumference of this circle. We know circumference formula from last class is 2 pi r. And we know that the r is, as I highlighted above, 6. So we're going to say 2 pi times 6. And that means the circumference is going to equal 12 pi. And it's going to be in centimeters because that's what it said originally. So that is the circumference of the entire circle, right? We did 360 degrees. Okay, the next one, part B, because we're just investigating here, says arc AB. So arc AB is talking about just this little portion right here. We want to know, first of all, what is the measure? It's equal to its central angle, so the measure is 90 degrees. But the length of it, well, we know that 90 degrees out of all the way around is 360 is really going to end up being 1/4 of a circle, because 90 out of 360 is 1/4. So if we know the full circle is 12 pi, then we can say 1/4 times 12 pi, and that's going to give us 3 pi, which makes sense. This is 3 pi for its length, and you would have 3 pi, 3 pi, 3 pi all the way around would get you 12 pi. So fractional work could help us. All right, let's keep going. Here again, the measure of arc AB is talking about the degrees. And actually, that's going to be 180. That's half. It's a semicircle. We know 180 out of 360, if you simplify that, that is a half of a circle. So if we want to find how long is that, the actual length of it, we want to find out what is half of the circumference all the way around. So half of 12 pi is going to get us a circumference for that part only, or a length of 6 pi. And I guess both of these are centimeters, centimeters, centimeters. Okay, so we've done a quarter, we've done a half. Now what? This next one's talking about arc AB, and it tells us that the measure is 120 degrees. So that information is given to us, so 120. So the actual length of it, you're going to apply the same logic. We know that it's 120 degrees out of 360. You're going to simplify that fraction. That's a third. So we have shaded a third of the circumference. So when you find the actual length, you're going to do a third of the circumference. Again, the circumference was 12 pi. So a third times 12 pi is going to give us 4 pi. Awesome. So we went ahead and we calculated all of those. So how are we going to do this every time? You're going to apply what we did pretty much every time. So arc length is going to be a certain fraction out of the circumference, or you can think a percentage of the circumference, or the fraction, which is the arc degree, out of 360 degrees times the circumference. So I like the fractional way. So I'll simplify my fraction and I multiply it by the circumference. Remember, circumference is equal to either pi d or 2 pi r, whatever you want to use. So you can kind of write the formula then in two ways if we go ahead and we plug it in here. So you could say, again, it's arc degree over 360 times 2 pi r, because that's your formula for circumference, or if you feel more comfortable with it, you can go ahead and multiply it by pi d. That's the same thing as saying 2 pi r, because 2 radiuses make up the diameter. So I kind of just like to think of it like this, because I know my circumference formula. But those formulas are all meaning the same thing, they just look different. So let's go ahead and apply it. So the radius is 15 here. Okay. So what I'm going to go ahead and do, and it's up to you, but I like to find the fraction first. So they did not tell us the central angle, but we can still figure this one out. We can still figure out what is the arc measure here. So what's the degrees? Since it's on the circle, I'm going to go ahead and double it. So this is 120 degrees. So I can find arc AB by saying 120 out of 360 times the circumference. So this is where the circumference go. What is the formula for circumference? 2 pi r. So times 2 pi, and the radius is 15. Again, this is just the formula for circumference. This is your fraction. So it's like your fraction times the circumference. So I'm going to go ahead and solve this. 120 over 360 is really just a third. 2 pi times 15, 2 times 15 is 30 pi. 1/3 of 30 is 10, and I still have my pi. And I'm done. All right. For this next one here, they want to find arc ST. Uh-oh, we don't know what arc ST is, but I have the angle 50 degrees and the arc 70. So there's kind of like my butterfly. So that's inside the circle. So it's in an interior angle. So the interior angle 50 is equal to the sum of its intercepted arcs divided by 2. So I'm going to call this x for right now. X plus 70 divided by 2. I'm going to go ahead and undo that. 50 times 2 is 100. subtract 70 from both sides, and x is 30. So that's the measure we care about. We care about 30 degrees. Okay, so arc ST, I'm going to do the fraction times the circumference. It's 30 degrees out of 360. And then my circumference is 2 pi r. It told me the diameter is 12, or you could do pi d, does not matter. So I'm going to do pi d since it has it for us, so 24 pi. So again, this is the circumference. This is the fraction, and you multiply them. So what does that get us? I'm going to simplify my fraction. 30 out of 360 is 112. And kind of just cross off the zeros, so it's like 3 out of 36. And then 24 pi, I like to write this way. 1/12 times 24 is 2. Still have my pi, and it's in inches. 2 pi inches. Okay, last example here is a little bit different. It's asking for the radius, okay? So a little bit different. We're still going to find out a lot of the same information. First, I always start with finding the measure. So if we go ahead and we take a look at the measure here, we know that this is 80 degrees. So we know, if we look at the formula just in general, that arc CD is equal to the fraction, which is the arc degree out of 360 times circumference. So we already know arc CD is 8 pi. They're telling us right here that it's 8 pi. So I'm going to plug in 8 pi for CD. So we're not finding it. We're working backwards. The arc degree, do we know the degree? Yes, we do. We know that it's 80 out of 360. Do we know the circumference? No, but we know that we can find it by doing 2 pi r. So notice that we know everything but r. So we're using the equation to solve. Okay, just like I always do, I'm going to go ahead and simplify my fraction. 80 out of 360, so it's really like saying 8 out of 36 is going to be 2/9 times 2 pi r. Now, it's kind of up to you how you want to solve it. There are more than one way. The way I'm going to solve it is I don't like the fraction. I'm going to get rid of it. So I am going to, actually, no, I think I'm going to go ahead and multiply 2 times 2 here. That's what I'm going to do. So 2 times 2 here. So 2/9 times 2 is going to give you, oops, 4/9 pi r. And then I want to get rid of that 4/9. I don't like it. So in order to get rid of it, I'm going to multiply by 9/4, the reciprocal. Whatever I do to one side, I do to the other. And that's because the 4 over 4 cancels and 9 over 9 cancels. So my left side becomes 9/4 times 8. 9 times 8 is 72. 72 divided by 4 is 10, 20, 23. No, 18. 72. Yes, 18. Wow, there's my math. Okay. 18 pi equals pi r. Actually, I could just do 8 divided by 4 is 2. 2 times 9 is 18. That's a lot faster to do it. I'm still not done. I don't have r by itself because, again, they want to know what r is. So to move the r away, or to move the pi away from the r, I'm going to divide. Notice that it actually cancels out on both sides. So we end up getting the radius is simply just 18. And the units we started off with were centimeters. So it's going to be 18 centimeters. And we are done. So we're still using the same formula. You're just using an equation to solve it for r. All right, that is it for the notes. And actually that's it for the notes for the unit on circles. Exciting. So please go ahead and start your homework.